Okay, so from the previous lesson, we learned how to calculate mass, volume, concentration using mole ratio. And if I give a mass, volume, or concentration, you can calculate the unknown. Okay, you can calculate the unknown mass, you can calculate the unknown volume required. Okay, so now we move on to just calculating volume of gases. Okay, there is a simpler way for only gases. Okay, so let's recall. Do you recall what Mr. Avogadro said about gases? He gave us this very special equation for gases, and that is molar volume. Okay, so for him, if you recall, Mr. Avogadro said that for gases, okay, equal volume of all gases under same condition, okay, they contain same number of particles, which means 1 mole of any gas occupies 24 dm cube at room temperature. So any gas, okay, oxygen, hydrogen, carbon dioxide, as long as it's 1 mole, they occupy the same volume. Okay, so this also means that the volume of the gas is proportional to the number of moles. So let's recall, it's 24 dm cube per mole, right? Per mole. So 1 mole is 24 dm cube. 2 moles is 48 dm cube. 0.5 mole will be 12 dm cube. So the number of moles and the volume is proportional. Okay, so if I have an equation that only involves gases, okay, I can just use volume ratio. I can just use volume ratio. Okay, so this is only for gases. So what do I mean by this? Okay, for example, take a look at this equation. Nitrogen and hydrogen, they can react to form ammonia. So from this equation, 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. So if I want to use volume, since the mole ratio and volume ratio, they are proportional, that means they are same. If I increase number of moles, my volume will increase proportionally. So if I want to convert it to volume, it means that 1 volume of nitrogen will be 3 volumes of hydrogen, and it will form 2 volumes of ammonia. Which also means if this is 24 dm cube, it will produce 48 dm cube of ammonia. Okay, so it's the same. Alright, so if I have 100 cm cube, it will be proportional, right? So 100 cm cube of nitrogen will react with 300 cm cube of hydrogen. I times 3, and it will produce 200 of ammonia. I times 2. Okay, because they're proportional. So if they're proportional, mole and volume, I can just use volume directly. So it means that I have 1 unit of this reacting with 3 units of this, and total I'll produce 2 units of ammonia. Okay, now we can only use it when they are gases. Okay, only when they are in gaseous state we can use molar volume. Okay, so what do I mean by this? So 2 moles of hydrogen reacts with 1 mole of oxygen. It will produce 2 mole of water. So this is what we know from the first lesson. 2 is to 1 is to 2, correct? Now, this is correct. Okay, which means 2 units of hydrogen, 2 units of hydrogen will react with 1 unit of oxygen to produce 2 units of water. Okay, but we cannot say 2 volume of hydrogen reacts with 1 volume of oxygen to form 2 volume of water, because this water is not in gaseous state. So these two I compare can, but once I bring in water which is in liquid state, cannot work. So it is not right for me to say this. 48 dm cube of hydrogen react with 24 dm cube to produce 48 dm cube. It is not right. Okay, because my water is not gas. I cannot use molar volume. So if I want to say this, 200 cm cube of hydrogen reacts with 100 cm cube of oxygen to form 200 cm cube of water, this is not correct, because water is not a gas. So I repeat, molar volume is only for gaseous substances. Okay, this molar volume is only for gaseous substances. Okay, so for gas, the volume is proportional to the number of moles. So volume is directly proportional to the number of moles. So we can use them interchangeably only for gases. Okay, please write down inside your notes. Okay, so let's try some examples. Okay, so using the same reaction. Alright, I have my nitrogen gas, hydrogen gas, and then they will form my ammonia. So unit mole ratio is 1:3:2. So if I'm given 10 cm³ hydrogen, question asks, what is the volume of hydrogen that will react? Okay, so since nitrogen and hydrogen, the mole ratio is 1:3, and they are all gases, I can use volume ratio. This also means that, okay, I will just calculate my volume of hydrogen, which is 3 times 10. Okay, so which is 3 times 10. So page 9 of your notes, okay, fill in part A. I just use 3 times 10 and I'll get 30 cm³. Okay. Now, some of you, if you ask me whether can you convert to moles, you can. You can do the long way and convert to moles. You will still get this. You'll still get this. Okay. Now, part B. What will be the volume of ammonia produced? So I'm comparing nitrogen and ammonia now. So nitrogen and ammonia is 1:2. I can straight away use volume ratio. Okay, so 10 cm³ times 2 is 20 cm³. Okay, likewise, can you leave your answer in 3SF? So 30 cm³ and 20.0 cm³. Leave it to 3SF. Okay, so if you want to use the mole method, the one that we learned previously, you can also do it, just that it's longer. You're prone to making more mistakes. So this part here is your guesses. So let's try the question on page 9. Give yourself about 3 minutes to 4 minutes, pause the video and try. Okay, so you are to write the equation yourself. Okay, so they tell you that butane, when it burn with oxygen, they produce these two. Okay, so butane is C4H10, and then when they burn in oxygen, O2, you'll form CO2 plus H2O. Okay, so they tell you that butane is 3 dm³. So in this case, we assume that they're all gases. Okay, they're all gases. And you need to balance the equation. Okay, you need to balance the equation. So to balance the equation, you take some time to balance and you will get this. Okay, I hope you get this without looking at the answers. Alright, so you are given this equation. This is 2:13 8:10. So you are given the volume of butane. Okay, so you have to compare volume of carbon dioxide with butane. So I'm going to just compare the mole ratio for this two. Okay, so the mole ratio for this two is 2:8. If I were to simplify, this is 1:4. So this is your mole ratio. And since they are gases, you can compare it to volume ratio. Okay, so if this is 3 dm³, this will be 12 dm³. So what is the volume of carbon dioxide formed? So I must write my statement. Volume of CO2 formed is equivalent to 12.0 dm³, 3SF. Always write your answer in 3SF. Okay, so this is how we do it. So as long as they are gases, you can use volume ratio directly. Okay, so in conclusion, right, butane gas, when they burn in oxygen, O2, they produce carbon dioxide and water. So they are all gases. I can use volume ratio. So I'm interested in carbon dioxide only. So I just compare carbon dioxide with butane. Okay, so the mole ratio is 2:8. Then I divide, simplify as 1:4. So every unit of butane, I form 4 units of carbon dioxide. Every 3 dm³ of butane, I form 12 dm³ of carbon dioxide. Okay, so this is the answer to 3SF. Okay, so this is a simple way of using volume ratio to calculate for gases only. Okay, so we have calculated readings for masses, volume of gases, concentration. Okay, so this part here is done, but we have not learned limiting reactants yet. Okay, we'll look at it in the later part of this topic. All right, so what is a chemist's favorite plant? Anyone knows? Chemist's favorite plant is stoichiometry. Ha ha ha. Okay, after learning about volume of reacting gases, we'll move on to concentration. Okay, so how to analyze volume, how to analyze concentration, that will be for volumetric analysis.